Hello, everyone. This will be a recording of the second lab for R for our class EXST 7005. The way that I'm going to do this one is, just from scratch. I'm going to show you exactly how I would do it if I were you. I would navigate basically to our section and click down here on labs and navigate to lab 2. And find the notes. Notice that this time, besides the actual notes here, we also have a folder here for results. And I want to make sure that we understand that we need to keep the structure. We need this kind of folder in order for the codes to work. Let me go ahead and download everything, basically. Let me download the notes RMD, the grades, the lab, and the actual notes, and download all that. It's going to zip things, and don't forget to unzip them if you're a Windows user. So it is a good idea to find like a space somewhere on your computer. I'm going to go ahead and put on the desktop. I have created a folder here called Lab02. So I'm going to put everything in there. Notice that when it comes down, it is compressed. Let me go ahead and unzip everything. So it is a good idea to extract all. It's going to give you a chance to choose a folder, but still what I would do is I would collect all that and then just drop them in here and delete all the other files, like the zip files and the folder that it created. So basically you should have these files, and as a matter of fact, you don't need the RMD, you just need the notes and the code. But if you're one of those folks that follow along how the notes were created using an R markdown, then perhaps you need that as well. Now, the way it is right now, it's actually not going to work. You need to create an extra folder in here by clicking new and call it results. The reason we have that now is because there's going to be a lot of output coming from this code. And if I just let them, populate that folder, it's going to look super messy. So what I have done for this code is I made it so everything gets saved inside a subfolder called results. But if that subfolder does not exist, the code is just going to, give you an error message. Anyway, let's go ahead now and check our notes and start working on our R code. I have in the back R Studio. Let me create a new script, and I will be putting things one by one, or you could just fire up the R code that I give you over there and just follow along. So what we're going to be doing is we're going to be creating, all those basic graphs that we discussed in class, and we're also going to create some summary statistics. So the very first thing is to basically read in our data. The data set that I chose today is, a sample of an old grade book that I had. It has some grades about the class that I was teaching, I guess, in Florida, and some other information about the students. Let's go ahead and plop that in here in a new R script. Give me a sec. My R Studio is giving me trouble. I don't know what's up here. Let me restart this real quick. And I'll pause the recording for a second. All right, so after I fixed the little problems over there, what we need is to create a new script, and I'll immediately go ahead and save it as, I don't know, something here. Let's see. Nope, it should be on the desktop, right? Desktop. And find the right folder. And make sure that you save it in the same file as everything else. I'm just going to call this one Lab02. Okay. And what we need to do first is we need to read in our data. In order to do that, we need to tell R through R Studio where our working directory is. That's why it really makes sense to have a dedicated file for the whatever you're going to use for Lab 2. Because right now what I'm going to do, since I saved this script in there, I'm just going to click on session, set working directory to source file location. So now R knows that all the files that I'm going to be referencing are going to be related to that spot right there. So let me go ahead and drop the first command, which is going to read in the dataset grades for us. And boom. And I'm just going to be naming it DF1. So this is data frame 1. Now, notice that in the previous lab, we had to use some libraries to read in an XLSX file. This one is a CSV file. It's a comma separated value file. And those are the typical way of distributing big data sets around, because there is no fluff, right? There's no, it's bare minimum. It's just the data. And it is one of the most efficient ways of presenting big matrices like the one that we're doing. And of course, R has a built-in function to read these types of data sets. Notice the syntax here, header equals true, just basically says that the very first line that you see over there is the variable name, and so read it as that. And then separator equals comma. The name comma separated values is because these are just basically lines, and to go from one cell to the next, you just put a comma. There are other ways to do that with a tab delimiter, space, and all that. So now this is a comma separated. This is the simplest syntax to read it in. And then again, remember, if you click on that here, left click, you can see how the data set looks like. And as I said, we have some student numbers here, like this is the identification of the students. And then the 6 quizzes, a midterm, and some extra credit. At the very end, we have a column with their gender. All right, so let's do some simple cleanup here, because if you notice the first row is actually the maximum points one can get. So we don't want that to be part of our data, right? That doesn't correspond to any student. So here's a quick way of removing rows. The code is going to create now a new data set, which I'm going to call DF2. And how is it going to do it? It's going to take the data set DF1 that we have, and it's going to remove the first row. So the syntax is row, comma, column. So the way that I did it here is I said, consider the DF1 and then remove its first row and keep all the columns. And whatever you get, name it DF2. So if we run this line, we're going to create a new data frame that only has 29 observations. This corresponds exactly to the student values, right? It doesn't have the max on the top. Does that make sense? I hope it does. And you can do the same thing if you want to remove a column and whatnot. So for now, we have now a completely clean data set that we want to do things like, find the summary statistics, graph it, do this and that. The first thing I want to try is create a simple scatter plot, and I will use the first quiz and the second quiz. And notice that in this case, these come in natural pairs, right? You can only do scatter plots if things are paired. They are, because they correspond to the same student, right? So that is the natural pairing. The library that I want to create good scatter plots is ggplot2, and you'll hear me use that a lot. It is indeed the best graphic library out there for R. So make sure again that you have it installed. I'm pretty sure we installed in the previous lab. If you don't, you know how to do it, right? You go down here to the packages and install ggplot2, and then you run it so that R knows how to use it. And then it's very easy to create a scatter plot. What you need to do is you need to say which data set to use, in this case DF2, and what's going to be on the x-axis, quiz 1, and what's going to be on the y-axis, quiz 2. And then just add what type of thing you want to do. The geom point is going to put like little points, right? Just like the scatter plot does. And then theme classic, it's just going to make this black and white background. There are various themes out there. Just explore them. Some of them are really cool. Finally, I'm doing all this and I'm saving it as plot 1. And if I want to see it, I need to kind of call plot 1 at the end. So when I select and run all this, here's my scatter plot here. And you can also zoom in if you want to see the whole thing. Okay, it looks a little bit bare bone. Again, I used classic theme and simple plots, but that's a good one, right? If we want, for example, now to do something a little bit more elaborate, we can just go all out, and I'm actually giving you here a link to the cookbook. Have fun. It's very, very interesting. Now, if we, let's say, want to save this scatter plot, we can do it two ways. The first one is to just click here at the export and save it as an image in this PDF. But the power of R is that you can use code in order to just do that automatically. So the next lines here are going to allow us to save this plot, which I named plot 1. And they're going to save it as scatter 1, as a JPEG and PDF. Now, notice here the syntax. I'm asking R not to save it just as scatter 1, but also go to this directory, the results, and save it as scatter 1. And as I said in the beginning, R knows how to do relational saves. So what it's going to do with this little dot is going to go to the folder where it's at right now. Basically, right now we are in the working directory that contains the code, and it's going to look for a folder called results. Okay, if it doesn't find a folder called results over there, this is going to give you an error. But now that we made a folder like that in there, it's going to go in that, and that's where it's going to save the scatter 1. So if I run these two, it tells me here that it saved the images. And if I go back and check on my lab 2, it's going to be basically inside here. You see? So it's going to be scatter 1. And there you go. So now it's saved as a JPEG. You can put it on Word. You can do whatever you want with it. All right. Now, let's continue on. Imagine now that I wanted to do a similar thing, but I want to somehow like showcase the two genders, right? The male and female. You can do that very easily. The code is practically the same. And I'm just going to name this as plot 2. Again, on the x-axis, I have the quiz 1, y-axis, I have quiz 2. And now you can just color these data points with some variable, in this case, gender, right? So what it's going to do is just going to create, same scatter plot, but now it's going to have different colors. Also, geom point here, you see it empty. There are so many arguments that you could put over there. So for example, I put shape equals 15. It's just going to change how it looks like. So let's go ahead and run that. These two lines are going to save it as scatter 2. And at the end, we're going to see how it looks like. So let's go ahead and click on that. And as you can see now, instead of like circles, we now have squares. All right, that was handled by shape equals 15. Once again, you can play around with the shapes, sizes, colors, you name it. All right. There's always, every time you do colors, there's always some legend. Again, you have the option to put the legend down here, over there, all sorts of things. ggplot2 is indeed amazing. Let me close that down. And remember, in the beginning, when we obtain our data, we want to do some exploration. And when you have multiple variables, like in the case of this example, when you have multiple quizzes, exams, and all that, what you want to do is you want to see how basically every variable compares to every other variable, at least the numeric ones. And so you kind of want to make these scatter plots for all possible pairs, if you'd like. The easiest way to do that is utilizing some technique like this performance analytics. So my goal would be to create such a scatter plot over there, right? Like basically not a scatter plot, but a connection of scatter plots. This actually has a lot more stuff. It has, for every value that you think of, it has a pair with every other value. And it also has the histograms over here. And then it also has correlation coefficients. We're going to learn that much later. Now, here's the problem, though. If I try to do everything with everything, I'm going to run into trouble, because if I go back and see my data frame, this one actually has numeric variables, but it also has these categorical variables. So it's impossible, right, to do a scatter plot between numeric and categorical. So we kind of need to tell R, hey, create a smaller data set that actually doesn't have that gender in there. So I can do like simple statistics on that. Or in other words, let's just keep the numeric variables. But not only that, the column student actually is not something that we care about. This is just an identifier, right? So although we're using numbers here, the student column is actually a hidden categorical variable as well, and we don't need it. these numbers are just basically a representation of the names of the students. I just de-identified them. So we kind of need to drop this one too. And finally, this last column with the extra credit, this is just two values, like 1 or 2. This is numeric. It's definitely discrete. We actually call it binary because it can only get 2 values. And this one is a value 1, 2, and it doesn't really help to do scatter plots with binary values. So what I want to do basically is I want to remove the gender, the extra credit, and the student column. And here's a quick way to do it. I'm going to be using a very powerful package or library called Tidyverse. And I'm pretty sure I've discussed this before. Tidyverse is maintained and expanded by the same folks that are responsible for RStudio. And it is the most prominent package to do any sort of data handling and data analytics in R. And it has like very simple features like the one that I'm going to present now that make your life a lot easier when you're trying to analyze data. Let's keep this piece and put it in our code. And first we need to invoke the library Tidyverse. Once again, if you don't have it, make sure you install it. All right, it's taking a little while because it's attaching a bunch of packages in the background. And again, if you don't have it, click on packages, click install, type Tidyverse, hit install. As long as you have internet access, it should work. Now, let's focus a little bit on this part of the code and understand what it's doing. First of all, we're going to be creating a new data frame, which I'm going to call df3. How are we going to be doing it? We're going to start from df2. And then notice this syntax. These are called pipes. And basically it says, take this, run it through this procedure, and then run it through this procedure. And instead of like writing it over and over, we use these little pipes. Imagine like something going on the left side of the pipe, something happens to it and moves on the right side of the pipe. So this way we take this data frame, and what we do here is we select all the variables that are numeric. All right, select if is numeric. So select the variables which are numeric. Now, R, especially if it's reading from CSV files, has a very good knowledge of what is numeric and what is not numeric. But it still sees student and extra credit as traditional numeric variables, right? Because they have numbers. So we need to basically specify remove those two as well. So you can add another select function down there that says, okay, select the ones that are numeric and also select everything except for student and extra credit, right? And it's a very nice workflow here. You just put various assumptions, various restrictions, and then at the end, when you run all this, you will get a smaller data set. And as you can see here, this one, so df3, click on it. It only has quiz 1 through midterm, right? It dropped the ones that we didn't want. Okay, so once again, let's go back to the very first class. Knowing what the variables are is super important, even in the code, right? Because if we just said keep all the numeric ones, we would even keep the student variable, which we shouldn't. All right, so now that we have the clean data set that only has numeric variables of interest, what I want to do is I want to create that matrix of scatter plots, as we call it. And the best way to do it is using this package Performance Analytics. Best way. There are multiple ways that you can do it, but I just want to introduce a little bit this library. This library is really awesome, and this is a great way to do it. So once again, if you don't have this library, make sure you install it. Actually, I don't know if I have it on this computer, so let me go and see. Yep, I did. And then the command to create the matrix of those scatter plots is called chart.correlation. And you need to tell it which data set to use and whether or not you're going to need the histograms in the diagonal, and then like some other arguments there to how to make it look. So basically, this is the output. And as I said, you get all possible combinations of scatter plots. You even have some sort of line that shows the general trend. We're going to talk about that when we reach linear regression. And then in the diagonal, you have, a simple histogram of the variable of interest. It tries to find, a certain number of boxes that it kind of looks good with an internal heuristic. On top of that, it also has distribution, the corresponding distribution. And then here, as I said, it has the correlation coefficients with the whether or not they are significant. So anyway, we're going to get back to that later on. What I want you to keep is, here's a nice way to create scatter plots for multiple variables at the same time. Okay, now let's continue on. If you do want to save that one, let's say this one, you can do it through the export. There's no GG save here, but instead you have to use this code where basically and this code works in practically everything that creates graphs. You can wrap the graph being created between JPEG and the name of it, and then a dev off. So basically this JPEG is going to say, whatever I'm going to create afterwards, save it as, I don't know, scatterplot matrix.jpg, and also save it inside the subfolder results. And then in order to tell it where to stop saving, you just have to put this div off, all right? So if you do this thing, you will notice that now inside my folder results, I also have the scatterplot matrix, all right? In case you want to, insert it somewhere. Okay, now, so that's for the scatter plots. And again, when we reach linear regression, we're going to do a lot more. Let's see now how you can create a simple histogram. And for that, I'm going to be doing a histogram for quiz 2, and I'm going to be saving it as well. I'm going to use again ggplot, and now my histogram is going to be plot 3. So select this part and drop it in here. So what this is going to do is it's going to create, and it kind of looks ugly here. Let's beautify it a little bit. Let's move that here. A little bit better because I want to be able to see everything. So again, we're going to create a new plot. I'm going to call it plot 3. You're going to be utilizing ggplot. I'm going to apply everything to data frame 2. In this case, I actually want the data frame that have the student names and the genders. You'll see why. And again, that kind of explains why I don't overwrite data frames. I just create versions of them because, for example, this is the initial one. This is the one that doesn't have, the number line with the total scores, and this is the clean numeric ones. But for example, if I want to do by genders, I cannot use DF3 because that doesn't have the genders anymore. So it's a good idea if you don't have a memory issue to do this kind of version control in your data sets as you're working through them. Okay, so what is this going to do is it's going to use the data frame 2, and on the x-axis it's going to put the quiz 2. And in order to create a histogram, you need to use the command geom histogram. And on the y-axis, you have the ability to do simple counts. The way to do that is with this one, or you could even do relative counts. And now it becomes a little bit tricky. What I want to do is I want to have the bins to start, let's say, from 0.5 and go to 8.5 by increments of 1. So like 0.5 to 1.5, 1.5 to 2.5, and so on and so forth. So the way to do that is basically specify where the breaks are going to be. The syntax is very easy. You create a sequence that starts from 0.5 and ends at 8.5 by 1. Okay. Now I add a couple of fluff here. I make the color of the rectangles red and the inside light blue. There's so many things that you can play around with it, by the way. So at the end, I also want to change a little bit what's going to be showing at the bottom. Let's say what are going to be the ticks on the x-axis. And in this case, I want to make everything from 0.5 to 8.5 increasing by 0.5. Finally, let's just use the simple classic theme and save the output as histogram underscore quiz to PDF and JPEG, but inside the folder results. Let me go ahead and do that. And this is what you get. I think it's pretty neat. The colors always amaze me here. All right. Obviously, you can play around with it. You can, swap out colors, change things around. But notice here, the bins are exactly as I wanted them to be, right? So they have the 4, 5, 6, 7 as midpoints here, and it all looks good. All right. Now, as I said, you can really go all out with these scatter plots and histograms. I'm sorry. In this case, I want to create what is called a stacked histogram, when you have basically a couple of groups. And what it's going to do is it's going to create the same histogram as I did before, but it's going to give a color to the genders. Now, this is not very informative in this one, but I've seen, you know, some really powerful graphs being created this way. And again, this looks messy when you do the copy pasting. Perhaps you can just use the code that I gave you and not have to copy paste from the notes. All right, so once again, see, this is tricky here. Let's make sure we put it there and put the theme classic at the very. All right. So again, it's going to do the exact same thing, but this time it's going to fill it in by gender. All right. So if we run this, you get this stacked scatter plot, right? It's the exact same thing, but you know, you get this. Let's also put the color here. In the geom histogram, let's put over here. Let's add, I don't know, color equals I just want to make sure that we see the different histograms popping up here. I think this is going to look a little bit better. Maybe not. And it's an equality sign here. There we go. Yeah, that might be a little bit easier because you can now see like where things break. Okay. So again, what is this? It's like the exact same histogram, but it just tells you how much in each box is contributed by, you know, each gender. All right. And again, you can change like practically everything here. All right. What I want to do now is I want to create some box plots, because that's, you know, the typical way of presenting one variable, one numerical variable, besides its histogram. And to do that, we will again use ggplot, but this time we're not going to be doing histograms, we're going to be doing a box plot. So the command, I need to again kind of clean it up a little bit. The command is geom box plot, but I'm also adding some extras here because that's going to make things look a little bit better. Let me get all this, delete, and let me get all this and delete. It should be okay, but let's do it like this. And yeah, once again, you know, this copy pasting business is a little bit tricky. If you just use the code that I'm giving you over there, this would be like much more streamlined. But again, what I'm doing here is I'm making a plot using ggplot2 and the data frame 2. Now, notice here that I don't have anything on the x-axis. Basically, I'm just saying that on the y-axis, put the box plot of quiz 2. So you just leave this one empty. And the first line is actually going to create those whiskers that we see in the box plot. The geom box plot doesn't create those, just creates vertical lines. And this controls how big the width of those is, completely up to you. Now, I've added this line, the stud summary. In a box plot, you typically don't see the mean, right? We have the median, Q1, Q3. I do like to see the mean, though, in all the box plots that I create, and this function does it. You can add whatever statistical summary you want by invoking the stud summary. The function that I want to use now is the mean. I'm just going to give it the color dark red, and it's gonna have shape 18. You'll see how that looks like, and size 3. So that's why I have this line over there. And finally, as I mentioned, ggplot2 is very customizable. I want to change the labels on the x-axis and the y-axis, and by using labs, you can say on the x-axis type quiz 6, and on the y-axis type frequency, because basically that's what you see. Actually, no, not frequency. I'm just going to leave this one empty. Okay. And then just theme classic at the end. And if I run this, there you go. So here's my simple box plot, right? And as you can see, you have this I don't know, rhombus shape thing, which is pointing to the mean. All right. And that's a very, very simple box plot with just one thing. It's also noticed saved as quiz 6 box plot, all right, inside the folder results. Okay, so another thing that box plots are really useful for is to create comparisons between two groups. And so, for example, here we have the two genders. We can kind of repeat the whole process. This time I'm going to be using the midterm variable, and I'm going to see a side-by-side box plot by gender for this. And I mean, the code is practically the same as we had before. You just, in this time, need to describe what's going to be on the x-axis. So if I grab this part of the code and run it, what it's going to do is going to create plot number 6, and it's going to add again an error bar, because we want to see those nice error bars on the top. And again, it's going to create a box plot, and again, it's going to add, whoops, I didn't need that. What I need is to remove this piece. It's again going to create the means, and it's again going to have all right, it's again going to have different labels, and on the x-axis we're going to have gender, and on the y-axis I'm going to put, I don't know, quiz 6, I guess, or midterm. This is for the midterm, I'm sorry. All right, and theme classic, and save it. And let's run this. Okay, so there you go. This is the side-by-side box plot. You can see the females and males. You can basically start making comparisons between the two. And then utilizing those comparisons, you can actually write tests to further explore it, right? We never make inferences just by looking at the graphs, but it's a good idea to like start thinking about what is possibly there and start looking at it in order to prove it. All right. Now, another big chunk for this first section of the class is to get those summary statistics, right? The ones that we mentioned. And it's quite simple to create those summary statistics with various packages. This package psych, package tidyverse will do that for us. And the command here is just basically describe. So I'm going to grab this too and drop it in here. I actually already have the tidyverse, but I do need this new library psych. Again, if you don't have it, make sure you install it. So run these two lines so the packages are turned on, and then the describe, and this basically needs to give it what data set you want, whether or not it should remove the empty ones, and the answer to that is most of the times yes, remove the empty ones, and then whether or not you need the skewness and kurtosis. We're going to talk about that in class as well a little bit, and I gave you some online resources for it. And then what kind of trimming you want to do. This relates to how many outliers you want to remove. Most of the times we remove a percentage of outliers. This trims 1% of the outliers and reports, you know, what would be the new mean, what would be the new deviation, and so on. So you can play around with that. This is like, I guess, 10%. And so the output kind of looks like this. You get a list of all the variables that you got over there, and then the summary statistics this way. Notice also that for gender, it has a little star here, which probably says, hey, I don't think this is numeric, and you know, take everything here with a grain of salt, right? And of course, this makes 0 sense because gender indeed is not numeric. If you want now to save this, for example, you can always name the output of the function describe as something. And for this case, I'm actually going to use the clean data set without the students and without the extra credit and without the gender. So I'm going to describe DF3, and I'm just going to keep, the basic statistics. So if you just do describe DF3 and save it as something, I'm just going to save it as some stats. And see now it is saved here as a table. So you can see now the different variables of interest and then the simple summary statistics. At the very end, you can also like write this one as a CSV file, and you can open it up in your Excel sheet. So let's go here to Lab02 and look into the results, and you'll see there's an Excel sheet called Summary Statistics CSV that you can just basically pass to somebody else that doesn't have R and they still want to see the statistics. So there. Okay. Now, besides just getting the summary statistics like that, you can also get it by category. So for example, if I wanted to find, what was the summary statistics for midterm for the two genders, again, I'm going to be using the library psych, and the code is this one, the describe by. So it's like, similar code. So you see the syntax described by, you need to tell it which variable you want. In this case, I'm going to use the second data frame DF2, and I'm going to focus exactly on the variable midterm. So DF2 $midterm, and you need to tell it how it's going to create the groups. In this case, it's going to create it by using a variable gender from data frame 2. Yes, do remove the empties, use the skewness and trim it by 10%. So we're going to run this. And as you can see here, you get the descriptive statistics by the two groups, for the females and for the males. This looks good and everything, but it's a little bit tricky because you can't really save this, and it's a whole mess. Instead, there is this very interesting combination between tidyverse and the package moments that creates a very clean output. Let me showcase that. And it's not just clean, it's super customizable. So like the next part of the code will do exactly the same thing that I did before. It is invoking the library moments, which I'm not sure if I have. See, I don't have this one. So let me go ahead and install it. Click install, go here to moments. There it is, and then install it. It's going to take a little while. Okay. Right, that works. And what I'm doing here is I'm creating a new file, a new data frame called mid summary. How am I doing it? I'm taking data frame 2 and I'm grouping it by gender, and I'm adding all the summaries, right? I'm adding, the actual counts. I'm adding the means of the midterm, the standard deviation of the midterm, the median of the midterm, the min of the midterm, the max of the midterm, the mean absolute deviation, of the midterm, the skewness, the kurtosis, the interquartile range, and I'm just, at the end dropping the groups. And so if I run this part of the code, I'm creating this mid summary, and as you can see, it's by female and male, and it has the variables that I care about, right? So the reason why I like this way is because now you can just, see this and save it, and it's a data frame, and it's like clean and clear, and you can put, only the ones that you care about. All right. So, and you can even like save that afterwards as a CSV file and give it to somebody else that can see it. And this is done by genders. All right. So I'm going to copy that, throw that in there, and it's going to save this data frame as a CSV file that I can pass to somebody else. All right. So check the notes. I'm giving you many, many links to go out there and explore further. But basically, this way is how you do simple statistics, simple graphs. And I'm pretty sure you're going to be coming back to this lab often, even at the second part of the class when we're going to be doing like higher level modeling and all that. You're still going to need the basic summary statistics. So make sure you understand this lab very well, and don't just copy paste things. Like try to practice, try to tweak the code, make it look pretty. All right. So that's all for this lab, and make sure that you ask questions if you have any on Moodle.